Today we are doing Unit 2A, Packet 3, Criteria for Triangle Congruence. So previously when we talked about triangle congruence, we knew two things that we had to prove in order to prove that triangles were congruent, right? We had to prove, countdown for the geometry EOC, we're still at 9 months. All right. For triangle congruence, we had to prove that, number one, all corresponding sides are congruent. And then, I'm sorry about the no room here. And number two, we had to prove all corresponding, that says corresponding, all corresponding angles are congruent. All right, so that was from Packet 1, right? All corresponding sides and all corresponding angles are congruent for triangles to be congruent. So that was a lot, right? Proving all three sides and all three angles were equal. So today we're going to learn some postulates that will take some of the workload off for us. Before we start anything, though, we need to know about the different types of triangles. So there's 4 different types that we focus on in geometry. Equilateral, isosceles, scalene, and right. My dog's chewing his dog toy. Here's my dog right now. Spencer. So sorry if he makes a lot of noise. All right. So equilateral triangle. A triangle with 3 equal angles and 3 equal sides. So we see here that they all have one congruent notch. That means all 3 sides are equal, all 3 angles are equal. Now, why does it say 60? Can an equilateral triangle have any other angle measurement besides 60? We'll come to that later. So just hang on to that idea for a second. All right, isosceles triangle, a triangle with 2 equal sides. So here I have this side and this side that are equal. As a result, I also have 2 equal angles, and they're the base angles that are across from the equal sides, right? So this is across here, and that's across there. All right, so equilateral. All 3 equal sides, all 3 equal angles. Isosceles, 2 equal sides, 2 equal angles. Scalene, no equal sides, no equal angles. So all 3 side lengths are different, and we can tell that because 1, 2, and 3, right? If they were all equal, they would all have 1 notch. Or if 2 were equal, they'd have 2 of the same. And then 3 different angles as well. So you can see that the congruent marks are different. This has 1 ring, this has 2, and that has 3. So all different angles, all different sides. And then my last triangle is a right triangle. A triangle in which one angle is a right angle. So if I have a right triangle, I know that from the square notation, right? So right triangles have 2 legs and 1 hypotenuse. The hypotenuse is always going to be across from the right angle, and it's going to be the longest side. The hypotenuse is always the longest side. All right. Now, could you have a right triangle that is also a scalene triangle? Yeah, you could, right? If one of these 3 angles is 90 degrees and the other 2 are not 90 degrees. Could you also have a right triangle that's an isosceles triangle? You could, right? If one angle is 90 degrees and the other 2 angles are different measurements that are the same, right? Okay. So now we're going to learn a theorem that you're going to use many, many times in this class. It's the sum of all the interior angles in a triangle. So I think I went over it with a few of you during the scavenger hunt today, but basically what you need to know is that all 3 angles in a triangle are always going to sum up to 180. So here, angle A, angle B, and angle C sum up to 180. That will always be true for the interior angles of a triangle. So a quick example right here, 82, 55, missing angle. Can I solve for the missing angle? I most certainly can. If I take 82 plus 55, I get 137. I'm going to take that 137 and I'm going to subtract it from 180. So 180 minus 137, and that's going to give me 43 degrees. So I know that this missing angle must be 43 degrees because all 3 must add up to 180. All right, go ahead and flip the page over. All right, I'm going to do number 1, and then I need you to do pause the video and do 2, 3, and 4. All right, so number 1, 55, 70, what's that missing angle? Sorry, let me focus this. What's 55 plus 70? 125. So if they all have to add up to 180, I'm going to take 180 minus 125, and that's going to give me my missing angle of 55 degrees. So this missing angle right here is 55 degrees. All right, so pause the video, do number 2, 3, and 4. Okay, we'll check those answers in class. All right, now solve for x. So with this, we're given an expression within one of the angles, and so what we need to do is use that angle sum theorem to solve for x. So I've got all 3 angles here. I've got 30 degrees, I have 66 plus x is this angle, and then the measurement of this angle right here is 90 degrees, because this means a right angle, right? So if I add up 30 plus 90 plus 66 plus x equals 180, all 3 of my angles are going to add up to 180. All right, so I'm going to drop the parentheses from that expression, and I'm going to combine like terms. All my constants are like terms. All right, so I'm going to add up 30 plus 90 plus 66 gives me 186 plus x equals 180. So I'm going to subtract 186 on both sides. That cancels out, and I'm left with x equals 180 minus 186. Okay, that gave me a negative number. That's weird. Can angles be negative? No, angles cannot be negative, but in this case, x is not an angle, right? X is just a variable that I'm solving for, and when I plug negative 6 back into this expression to find this missing angle, 66 plus a negative 6 is going to give me 60. So my missing angle is not actually a negative number. My missing angle is 60 degrees, right? Okay, so go ahead and do number 6 on your own. Pause the video. All right, now that you've done number 6, we'll check that in class. All right, here's a quick Unit 1 review. You should be able to do all of these without my help, so I want you to pause the video and work through each of these. It's a translation, a reflection, and a rotation. All right, once you come back, we'll flip the page over. All right, here is the actual bulk of our lesson. So we said if 2 triangles are congruent, we know 2 things. I reviewed it at the very beginning of the video. We know that all corresponding angles are equal, and all corresponding sides are equal. So we got tripped up on that congruence card sort because we thought some things that just said all the angles were congruent meant that the 2 figures were congruent. And I told you had to prove that all the angles and all the sides were congruent. So do I need to prove that all 6 of these parts, and by 6 I mean triangles have 3 angles and 3 sides, right? So do I need to prove that all 6 of these parts are equal to prove that 2 triangles are congruent? Not after today. We do not need to confirm that all 6 parts are equal. Usually confirming 3 out of the 6 is enough to prove that the triangles are congruent. They just have to be in the right order. So again, order matters just like it did in congruent notation. All right, so I've got 5 different ways that I could prove 2 triangles congruent. So you're going to see these 5 different ways over and over again, and we're going to use them in geometric proofs. All right, so ordered combination. This word ordered is important. It must be in this order. So ASA stands for angle, side, angle. And that order is important. It has to be in this order. So 2 angles and the included side. Do you see how the word side is in between these 2 words angle? It means that the side has to be in between the 2 angles that are congruent. So if triangles have two angles and the included side that are congruent, we can automatically say the two triangles are congruent. We don't need to prove that all 6 parts are congruent. So here I have this angle and this angle. I have this one and this one. And then the side that's in between the two angles is also congruent. So are these two triangles congruent? Yes, they are. Now I'm going to go ahead and name this triangle so we can actually write out a congruent notation. Alright, we know that angle A is equal to angle D. We know that angle B is equal to angle E. And we know that C is equal to F. And that's based on the congruent notation in the triangle. So I'm going to say that triangle ABC is congruent to triangle DEF. Alright, so that's angle side angle. So what do you think SAS stands for? It stands for side angle side. Alright, side angle side. So if a triangle has SAS, it has side angle side. Two sides in the included angle. Do you see how the word angle is in between the two sides? So it has to be the included angle. This angle is in between the two congruent sides right here. If it were this angle, that wouldn't work. If it were that angle, it wouldn't work. It's got to be the included angle. Alright, so I have two sides and the included angle that are congruent, so these two triangles are congruent. I don't need to confirm all 6 parts. I have enough to say they are congruent by side angle side. Alright. I mean SSS, which stands for side, side, side. Sorry about my lame jokes. Alright, 3 sides of a triangle are congruent to 3 sides of another triangle. So this and this are congruent, that and that, that and that. I don't need to prove anything about the angles. If I know that all 3 sides are congruent, I can automatically say that these two triangles are congruent. It does not work the same way with angles. I don't have an AAA. You can see that at the very bottom. Don't get confused. Angle, angle, angle does not work. Side, side, side does, but angle, angle, angle doesn't. Alright, AAS, angle, angle, side. Angle, angle, side. So if 2 angles in the not included side are congruent, then the 2 triangles are congruent. So what I want you to do is always take your pen or pencil and trace along and just kind of say the words out loud as you hit them. Angle, angle, side. Angle, angle, side. Angle, angle, side. So if the 2 angles in the non-included side are congruent, I can say the 2 triangles are congruent using angle, angle, side. Now what does not work is side, side, angle. Side, side, angle. We don't want to spell out any curse words, right? Even though this is spelled out backwards. So think if what you're actually, if you're spelling out angle, side, side, think that that is not the word you want because it does not work for triangle congruence. So I've got angle, side, angle, side, 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 and angle, angle, side. This last one's a little bit different. HL, it stands for hypotenuse leg. Now this only works with right triangles. Only works with right triangles. So if you don't have a right triangle, you cannot use HL. You could use one of these others, right? But not HL. So if you have a right triangle and the hypotenuse and one leg are congruent and corresponding, then your 2 triangles are congruent. So first of all, how do I know these are right triangles? They both have a little box right here. And then my hypotenuse is what's across from the right angle, right? And the longest side. So it has to be the hypotenuse and one other leg. Could it have been this leg instead that was congruent? Definitely. But it's got to be the hypotenuse and one leg. All right, let's flip it over and start doing some problems. All right, you're going to use your SCHAVAS knowledge and knowledge of these common properties right here to figure out if angles are congruent using those 5 different theorems and postulates that we just talked about. All right, so these 4 things are pretty common in questions about triangle congruence. If you see you have 2 triangles here, right? You have this triangle